Hello, so this is experiment 720 for the process measurements lab. Now, in the process dynamics lab, there will be another apparatus exactly the same as this one sitting here in place of this apparatus. And what we're going to do on here is we're going to look at pressure control inside a tank. So we have a device that takes an input signal and translates that into a pressure, and it will pressurize this tank based on the input signal from the controller. But since right now we're not going to use the controller to control the system, we're only going to use it to read the output of the transducer, and we will control the final control element manually. So first thing we need to do to start this up, we're going to go ahead and close this. This is a flow meter on the out, so I can discharge fluid from inside the tank. You can think of this like, for example, this is like a reactor where you have some chemical reaction going on and you're building moles of gas. And so the pressure starts to go up as the reaction goes. And then you either bleed off some of the pressure and send that to some other process or take it off as product. But you found that for a particular reaction that the yield is maximized when the pressure is at some set point value, say, I don't know, 15 psi. And so you'll want to control the pressure inside this tank so it stays at 15 psi. And you may have some process upsets that throw off your pressure, and your controller has to act to keep the pressure constant at 15 psi. So to supply, for this particular experiment, we're just using air, and we're going to pressurize this tank. But first thing we're going to do is open up the main tank valve. The regulated pressure is set to 50 psi, and we're just going to leave it at 50, so please don't change that setting. Okay. And we're going to get some experience with how much gas we go through from this tank. But we're going to set a maximum, currently we'll set a maximum airflow rate out of the tank to be 50 liters per minute. And so we can see that without any power going to our transducer, that we're actually getting a little bit of pressure in here. And now we're reading in counts. This is set up to read in counts, just like the other experiments, so it's not any kind of engineering unit. And to apply power to the final control element, we're going to turn on a variable DC power supply. And the current should be set to maximum, the voltage should be set to 0, just like it is there. And to read the signal going into the final control element, we'll use a multimeter. And when you come in for recording, you'll get to see what all this is reading. And so I'm going to go ahead and apply some power to the final control element. And as I do, you can see the pressure starting to change. And let's say we want our set points at 15 psi. And as you can see, when we stop changing the signal, the pressure stabilizes. And we're a little bit above, so we'll just reduce the pressure a little bit. There we go. And a little bit of finagling, you can get it right at 15. Now, what happens though if you have some bleed off from here that reduces the pressure? So, as you would expect, with the same input signal, I haven't changed the input signal, our pressure has dropped because we've got some flow going out of our tank. Well, that's going to be part of the control problem. What is our range of control on this particular apparatus? With, say, the flow rate coming out at 20 liters per minute, and we want to get the pressure back at 15, so we're going to have to increase the signal to the final control element. Now, of course, as we did that, the flow rate may increase a little bit, so we may have to dial it down just a little bit to get back at 20. But you can see the difference in signal that you have to apply to the final control element, the difference in power, when you actually have some flow going out. And what you'll want to look at is at different flow rates, how much do you have to adjust the power? And it doesn't look like right now we have to adjust it at all, so it's okay. But at some point, we're going to have to change the power setting. And this may be different at different pressures. So let's say at 5 psi, and we have the same flow rate out, that it takes a different amount of power than it does to keep it constant at 10 psi. So that's something that you'll be able to explore. So at the end, you want to shut off your main tank valve, and we're going to turn off power of the transducer. That's off. Shut this off. That off. Shut off our meter, and we'll bleed the pressure out of the tank. And there you go. So you can come up with different ranges to explore. Now the output of this transducer only goes to 30 psi. This tank can take up to 120. This gauge goes up to 60. So you can work anywhere in that range, but again, keep the outlet flow rate limited to an upper level of 50 liters per minute.